Hi everybody, right now we're going to do 5.2. This one is simplifying fractions, and we're going to start off talking about just general fractions with the numbers when you don't have variables. So if you already know how to reduce fractions, the first part might not be anything new to you, which is fine. Just make sure you skip ahead and watch the last part where we talk about what to do when you have variables. We've kind of actually already talked about it, so it shouldn't be anything too new. Also, we'll talk about how to reduce improper fractions as well. So those might be new to you. You might want to make sure you watch for that. Okay, so simplifying fractions. So when we did 5.1, we talked about if I had 3/4, and yes, this is on my dishwasher. It makes for a nice small area so you can see the numbers better. If I model that with a pizza and I cut it into fourths and I have 3 pieces, so I have 1, 2, 3, 3/4 and 6/8 are the same fraction. And I know this in my model. If I cut it into 8 pieces, I need to grab my red marker so you can see it better. Hold on a second. So if I cut it into 8 pieces, so there's 1, 2, 3, 4, 5, 6, 7, 8 pieces, but I only have 1, 2, 3, 4, 5, 6. So 6/8. Remember, the 8 means how many pieces it's cut into, and the 6, the numerator, is how many pieces we have. So 6/8 and 3/4 are the same. 3/4 is just the reduced version of 6/8. How we get that is we pull out any number that would both go into 6 and also into the 8. I know they're both even, so I know at least 2 will divide into them. So the thing with fractions, it's kind of like equations. When we do equations, whatever we do to one side, we have to do the exact same thing to the other side. With fractions, whatever we do to the top, we have to do also that exact same thing to the bottom. So if I'm going to divide the numerator, the top, by -2, or not negative, excuse me, by 2, then I've got to divide the bottom by 2 as well. So 6 divided by 2 is 3, 8 divided by 2 is 4, and then this is my reduced fraction. I know it's reduced because the only thing that would go into 3 is 3. The only thing that will divide into 3 is 3. And so if I try to divide 3 into 4, I'm not going to be able to do it evenly. And that's what's important. It has to go into it evenly. The same number has to go into both the numerator and the denominator evenly. And that reduces your fraction. Okay, so we've just reduced 6/8 to 3/4. That's basically what we're doing in this section. We'll start off, I'll show you another one, how we can do it 2 ways. I'll show you. So the way that I usually do it, and I would say most people do it, is you just kind of think it through. But some people struggle with that because they're more process kind of people. And so I'll show you another way that you can solve it using the prime factorization trees, if you remember when we did those. So we'll have 2 ways, and if one way suits you more than the other, then that's totally fine. You don't have to remember the other way. Okay, so let's do 24/54. So I look at this and I go, okay, what's going to go into 24 that will also go into 54 evenly? Couple options. You can look at it and go, well, they're both even, so I know 2 will. So we could try that. So if I just divide both of them by 2, then I end up with 24 divided by 2 is 12. 54 divided by 2 is 27. And then I kind of reevaluate. So after you've divided something into both of them, you reevaluate, meaning you're going to look at the fraction and make sure you've reduced all the way. In our case here, we have not. I know this because I know 3 will go into 12 and 3 will go into 27 because 3 times 9 is 27 and 3 times 4 is 12. So I can start by saying, oh, well, I know 3 would go into that one and 3 would go into that one. So I'm going to divide both of them by it. And 12 divided by 3 is 4. 27 divided by 3 is 9. Now again, like I said before, you just keep reevaluating. So I look at it and I say 4 divided by 9, or not 4 divided by 9, 4 go into 9, basically 9 divided by 4, and it won't go into it evenly, so I know I've gone all the way I can go. The only other option would be is if 2 went into 9, because I know 2 is a factor of 4 as well. So this is completely reduced. I get it down to a point where there's nothing that will divide into both of them evenly. Okay? So this is what I call the chiseling down approach, or chipping away. You just are making the number smaller, the fraction smaller and smaller and smaller. If in the beginning somebody, like I always say Bob, said, oh, I know that 6 goes into both of those because I know 6 times 4 is 24 and 6 times 9 is 24. Let's do 6. That is a great number to do. You want to pick the highest number that you can think of. So if you look at it and you knew that 2 went into both of them, but you also thought of 6 as well, then you should go with 6, because you want to go with the higher number, because then you'll skip a step basically. It'll just chisel it down faster the higher number that you divide out. Okay, so here we have 24 divided by 6 and 54 divided by 6, which lends to 4 9s. And then we revise again. Is there anything that will go into 4 that will also go into 9? Nope, there's not. So we're done. So that's simplified. Okay, what happens when we have a negative? So let's say I've got negative 140 over 196. Okay? So if you remember a long time ago, sorry, my son just came in. I had to say hi. A long time ago, we talked about figuring out if a number would divide specific numbers. And we talked about a few tricks. We talked about looking at the last number. If it's even, if they're both even, then 2 will go into them. If it's 0 and 5, then 5 would go into them. If it's just 0, 10 will go into it. If it's 3, then you add the digits, so like 1 plus 4 plus 0, and whatever that equals, if 3 divides that, then you can go into it. Or 9 is pretty much the same rule. You add the digits, and if 9 divides that number, then 9 would go into it. Those would be good rules to go back over, because it would be really helpful for this, because I'm trying to find a number that will divide into both of these. I know 3 won't, because I happened, when we were just talking about it, 1 plus 4 is 5, plus 0 stays 5. 5 is not divisible by 3, so I know 3 is not an option. Worst case scenario, you don't want to think and you go, well, they're both even, so I know 2 does. Go with that, because once you chisel it down a little bit, sometimes those numbers become a little more obvious to you. So let's try that. We'll just reduce it by 2. Also, notice we have the negative. The negative, the only thing it does is it just means that we've got a negative whatever we have here. So once we reduce it, it's the same, it's still a negative. It's just a negative. Remember this, we're not changing what this fraction represents. We're just changing the way, or the numbers that it's written with. We're just reducing it. Okay, so I divided by 2. I get 70. Whoops. And I put my negative out here. I don't know if I mentioned when I was talking about that. Then I'm going to divide 196 by 2. So that's going to be 98. And now I have 70 98ths, or a negative 70 98ths. Okay, so now I need to figure out, is there anything that would also go into 70 and go into 98? If so, then I'm not done. I have to keep going. And I happen to notice that they're both even, so I know at least 2 would. So maybe you come over here and you just keep going with 2, which is fine. But again, if you notice a larger number in the beginning, then divide that out. So I'm going to divide my numerator by 2 and my denominator by 2. Whatever you do to the top, you have to do to the bottom. So 70 divided by 2 is going to be, oh, I'm going to write my negative so I don't forget about it, 35. 98 divided by 2 is going to be 49. And then I stop and I look at my numbers, 35 and 49. Is there anything that will go into 35 that will also go into 49? I know that 7 will, so I'm going to divide both of them by 7. That takes me to 35 divided by 7 is 5, and 49 divided by 7 is 7. Okay, now I look again, reevaluate. Is there anything that will divide into 5 and into 7 evenly? No. So I'm done. So negative 5/7 is my reduced fraction of negative 140 over 196. Okay, so that's reducing fractions. I'm going to show you this time a different way to approach it. I'm going to use the same fraction. So I'm going to do my negative 140 over 196. Okay, so this is the other way of doing it, the more structured way. It's using our prime factorization trees. Okay, so you're just going to take the numerator and break it down, make a prime factorization out of it, and then you'll take the denominator and do the same. So I'll start with, I'm going to do them down here, 140, and make my prime factorization. Well, I know that is, remember these two numbers have to multiply to make whatever they're forking off. So what times what makes 140? Lots of options. I'm going to do 14 times 10. It doesn't matter what you pick as long as it multiplies together to make 140. Then I have to keep going until I get all prime numbers. 7 times 2, or 2 times 7, times 2 times 5. And those are all prime. 2 won't break down, 7 won't break down, 2 won't break down, and 5 won't break down. Okay, so I have all my prime numbers. I'm going to write them up here. So 2 times 2, and I'm writing them in order, times 5 times 7. So I just did 2 times 2 times 5 times 7. Just rearrange them. Okay. And remember, when you multiply these, they should make that. So you can check. Okay, 196. We need to factor it. What times what will make 196? The only thing that comes to mind right off the top of my head is 2 times 98. Okay, so now I'm going to break that one down. 2 comes down, my 98. I'm just going to do the 2 again, but it's fine if you choose to do that. So 2 times 49 gives my 98. Bring down my 2, bring down my 2, and break down my 49 to be 7 times 7. So now I have my bottom row and they're all prime. So I'm going to write them back up here across from the 96. 2 times 2 times 7 times 7. 2 times 2 times 7 times 7. Okay, now remember, anytime we have all multiplication upstairs in the numerator and downstairs in the denominator, there's no addition and subtraction to throw things off. We can pull out, essentially. So like if I cover this up, if I pull off that 2 over 2, remember anything over its identical self makes one whole. So if that is essentially a 1 times anything just remains itself. So that 1 isn't changing anything. So what essentially is happening is our 2's are canceling each other out. This 2 will cancel that one out. This 7 will cancel that one out. And then this 5 won't cancel anybody, and that 7 won't cancel anybody. You can't cancel this guy. Again, he's already been canceled with that one, or paired up to make one whole, basically. So we end up with 5/7. If you remember from the last time we reduced this fraction, that's what we ended up with. Don't forget the negative that's out in front. It's kind of an afterthought, but don't forget about it. That doesn't look like a very good negative. Okay, so you end up with negative 5/7. So you can do prime factorization trees and then reduce your fractions that way. Sorry, I don't know if you could see that. Turn it wide. Okay. So you end up with your negative 5/7 by canceling once you have all your factors listed, your prime factors listed. So that's one other option. I'm only going to show that one way, where you can rewind this or stop it and pause it. That you can go back over that if you need to. Let's talk about what to do when you have variables. We actually have kind of done problems like these when we were doing the division, when we were dealing with the polynomials. So this time we're just going to have a smaller denominator coefficient and a larger denominator coefficient, basically, is going to be the difference. Okay, so we've got 9x to the 4th over 24x to the 3rd. Okay? So what we want to do here, before I told you to ignore the variables when we were doing the division, ignore the variable part and just deal with the coefficients first, then deal with the variables. So same thing kind of here. We're going to just look at the coefficients. I'm trying to cover up that x. There. So I've got 9/24. So you've got to reduce that fraction. So what will go into 9 that will also go into 24? 3, right? So I divide this guy by 3. If I do it to the top, I do it to the bottom. 9 divided by 3 is 3. 24 divided by 3 is 8. Okay, so now I've got to revamp and check and make sure it's reduced all the way. 3 will only go into 3, and it won't go into 8, so I know I'm reduced all the way. So that's great. Now I move on to the variables. Remember, this is just like we were doing before. If you've got a variable with an exponent divided by a variable with exponent, remember all variables have exponent. Even if it's not written, it's 1. It's an implied one. So if you remember the general rule, you just subtract the variables. So we'll do 4 minus 3. If you can't remember that, try to visualize that we have x times x times x times x, that's x to the 4th, over x times x times x, that's x to the 3rd. So these guys would make a 1, these guys would make a 1, and these guys make a 1. So those all cancel out, essentially leaving us with just this lonely x, which is what we would get if we subtracted. We'd do 4 minus 3, which is 1. So we would end up with x to the 1st power. I personally like to visualize it. I think it's more helpful. It helps you to see where the x's end up, because eventually we're going to start talking about what happens when you end up with the x's in the denominator and not just the numerator. So I like to think if I've got 4 upstairs and 3 downstairs, 3 are going to cancel 3 up there, leaving me with 1 guy upstairs. And again, you don't have to put the 1 exponent. You can if you wish. So this is our reduced fraction right here. We've reduced the variables and we've reduced the coefficients. Okay, let's try another one. I know you can rewind it, but we'll go through this one a little quicker. Won't do step by step. How about I throw in another variable as well. Let's try we'll talk we won't talk about it. I'll show you another trick that I was just thinking that I need to tell you about. Okay. So here we've got 20m squared times n over 40m. Okay? So I want to reduce my coefficients. So I'm going to look at 20 and 40 and think what would go into both of those. Hopefully you notice, oh, well 20 will go into 20 and it will go into 40. It's a great way to approach it. Look at the smaller number and see if it will go into the larger number, because then you know you're going to end up with the biggest number possible. Okay, so I'm going to divide both of them by 20. That leaves me with 1 over 40 divided by 20 is 2. Okay, so I've done my coefficients. If you want, you can scribble that out so you know you've worked with it. Now I've got 2 m's upstairs and an n. Okay, don't let this part confuse you. It's basically just saying m times n over m. Okay, that n can't be touched because there's not an n on bottom. Sorry, that m looks really bad. Okay, but those m's could cancel each other out. So this is what I'm left with, mn. So I've got an mn left upstairs. I like to do it like this. I go, this m will cancel with an m up there. So I'm left with mn. Please don't do that.
Hi.
Because I'm recording this. You want to say hi?
Hi.
That's my little boy Cole. Okay. Okay, so this is a reduced fraction. You end up with 1 mn over 2. Again, you don't need to write a 1. Anytime your 1 is our coefficient, it's not necessary. So if you put mn over 2, that's completely fine. And if it's written more like this, it looks a little better. But it doesn't have to be. Okay, I wanted to show you this trick really quick. So I'm going to put up our 20 over 40. And I can't remember if I had a negative on that one or not. If I did, you want to make sure that you carry the negative. I don't think I did, but remember your negatives. Don't forget your negatives. Okay, so here's a trick with fractions. So anytime they end in 0, the numerator and the denominator, if they end in 0, you can cancel off the zeros at the end. Essentially what you're doing is you're dividing both of them by 10. So then I'm left with 2 fourths. I still need to reduce because 2 would go into 2 and it will also go into 4. So I divide that by 2 and divide that by 2, which gives you 1/2. This one, it's probably easy to just see that 20 would go into 40, so you might want to just divide both of them by 20 from the get-go. But if I had a number that looked something like 70 over 1900, that one, it will make it a lot nicer and easier if we cancel zeros at the end, because then we're not dealing with as large of numbers. So what I would do is cancel these zeros. Notice I'm not canceling this other 0. It doesn't have another one upstairs to cancel it out. Again, I'm just dividing both of them by 10 essentially. And so then I'm left with 7 over 190. And then I have to think, okay, well, 7 go into 190 evenly? I just happen to know that it won't, so we are reduced all the way. Let me show you another setup. I'm going to do 1900 on the bottom again, but I just want to show you what to be careful for. If I have 1010 on top, okay, I told you that you can cancel zeros. Notice they have to be at the end. I can't go like this. Why not? Because what I'm doing is I'm dividing it off the end, and if I divide that off from up there, it won't work out. So, because that one holds a place, and it kind of messes things up, so that trick doesn't work for that. Okay? But we can cancel off those last ones. Okay, so that's that trick. I think we're almost done. I just wanted to talk about when we have mixed numbers, how do we simplify that one? Oh, actually, there's one more thing I needed to talk about with the variables. Sorry. Let's do one that looks like this. We'll do -14, a to the 4th, b to the 5th, c squared over 28 a to the 10th, b, and c to the 7th. Okay, hopefully you can see that. Okay, again, don't be stressed out because it looks overwhelming. Let's just go slow. So I've got -14 over 28. Hopefully you notice that 14 would go into 28 evenly, because then we'll go fast as far as chiseling it down. If you go, oh, well, it's even, I'm going to divide by 2, that's fine. You just have to keep remembering, or you have to keep reevaluating to make sure you've reduced as far as you can. But like I said, it's really good strategy to go and take the smaller number and see if it will divide into the larger number evenly, and then use that as your reducer. Okay, so I'm not going to forget my negative. And then I did 14 divided by 14. That will give me 1. Downstairs I did 28 divided by 14. That gives me 2. And now I'm ready to move to the variables. So upstairs I have 4 A's. Downstairs I have 10 A's multiplying. So 4 are going to cancel with 4 downstairs. So if I take 4 away from that 10, that leaves me with 6. So notice my A is to the 6th power, and it's downstairs this time in the denominator, because I had more in the denominator than I had in the numerator. Okay? Sorry about the doorbell. Okay, if I have b to the 5th and b on the bottom, I am going to cancel one of these b's with one of the b's upstairs, so that would make 4 b's left upstairs, so b to the 4th. So I'll write that. B to the 4th was left in the numerator. Okay, again, I've got 2 upstairs, 7 downstairs, so 2 will cancel with 2 downstairs, and that leaves me with 5. So I have c to the 5th. Okay, hopefully you understand that, and you can go back over it if you don't. I'll move on and we'll do mixed number simplification, simplifying mixed numbers. Hey, Cole? Cole, you need to take that in your bedroom or downstairs. It's too noisy. Thank you. I know, but I can still hear it. Okay, sorry about that. Okay, so we have 30/80ths we're going to do, or 30/8. Okay, if I'm going to reduce that, you have a couple options. You can start off by reducing and then changing it to a mixed number, or we can change it to a mixed number and then reduce. Everybody's kind of got their preference. I really don't care what you do. You can do it either way. So if you want to reduce, let's do it both ways. If you want to reduce first, if you divide this by 2 and divide this by 2, I picked 2 because I noticed they were both even, and the only things that go into 8 are 4 and 2 and 8, and I know 4 and 8 won't go into 30, so I went with the 2. So then I end up with 15 over 4. Okay? I know that is reduced, but remember I want it written as a mixed number. Do you remember how to write it as mixed numbers? 15 divided by 4. So you just divide it. 15 divided by 4. 4 goes into 15 3 times. 3 times 4 is 12. Subtract, and I get my 3. So remember, there's your whole number. You go around and pick up your pieces. So we end up with 3 and 3/4. Okay? So 30/80 is 3 and 3/4 simplified. Notice my 3/4 is reduced. It's a reduced fraction. So you'll see how that comes in handy. So that's all we do. There's nothing more to it. So you can reduce the fraction and then divide it, and then you have it as a mixed number. Or, sorry, I'm covering it up. Or you can do it the other way, which is don't reduce first and then divide first. So I just do 30 divided by 8. So 8 goes outside. Okay, 8 goes into 30. How many times? 4 times would be 32, so that's too much. So I've got to go with a 3. 3 times 8 is 24. Subtract, I'm going to borrow. This becomes 6. Okay, there's nothing else to bring down, so I'm done. So I have my whole number, and I pick up my 6/8. Okay, notice. I'm going to get it closer so you can hopefully see it. 6/8 is not reduced. So you have to reduce that fraction. You ignore the whole number. The whole number stays. Whatever you get, that stays. But you have to reduce your 6/8. So I know 2 goes into 6 and 8. So if I reduce that, I get 3. Remember my 3 wholes. 6 divided by 2 is 3. And 8 divided by 2. Sorry, you can't see what I'm doing. 6 divided by 2 is 3, and 8 divided by 2 is 4. So now I have my reduced mixed number. Okay, so your options for mixed number are to divide straight off the bat, and then you're going to have to reduce this guy, or you can reduce and then divide. Either way, it'll work out. Okay, I think that is all we need to talk about. Let me just double check really quick. Oh, I do want to talk about one more. In your homework, you have a problem that says, if we consider a year to be 365 days, what fraction of a year is 45 days? So if a year is 365 days, what fraction of a year is 45 days? So we have 45 days, and an entire year is 365 days. What fraction of the year is just 45 days? So that would be 45 over 365. They want you to reduce that. Okay, so you'll have to reduce that. I'm not going to go over that, but I just wanted to talk about how you would come up with the fraction part of it. Okay, I think that's it. I'm going to give you your assignment, and good luck with it. So this is 5.2. You're going to be doing 3 through, sorry, I've got to double check. 3 through 24, multiples of 3. Whoops. And then you're going to be doing 31 through 49 odd. So all of the odd problems, odd numbers like 31, 33, 35, 37, 39, 41. I gave you more of those just because these are the problems that you're really going to be dealing with, and so you've got to really understand those really well. Okay, I hope all is going well and you understood that lesson and you're liking the video format, and you'll look for 5.3 maybe tomorrow. If not, if you're feeling up to it, do it right now. Okay, thanks. See you later, guys.